Fine. So today we are going to start VRF, virtual routing and forwarding. Virtual routing and forwarding. VRF. And in VRF we are going to start first of all light VRF. Actually one VRF is equal to one router. Have you heard about the VMware before?
Yes, sir.
VMware, like I have this VMware, and with using this VMware workstation I can install multiple machines onto this physical machine, right? Similarly, like here I have installed this Microsoft server, right? Similarly, on a single router you can create multiple routers, multiple instances of routers. Like you can create multiple virtual routers on a single physical router. I got my point? That's called VRF. So VRF is a virtual router actually. So you can create multiple VRF on a single device, on a single router. And the point is, why do we use this VRF? Like for an example, if you are having a customer, not a single customer, you are having multiple customers, right? And all those customers asked you to separate their routes as well as to separate their traffic, right? Now it is not possible, it is not going to be possible for service provider to provide a separate router, a separate device for each customer, right? That's not possible. But what can we do? We can create multiple routers on a single physical router, and we can dedicate a virtual router to a specific customer. We can dedicate a virtual router, a dedicated virtual router to a specific customer, right? To a single customer. So it is possible. So basically now with the help of VRF we will be creating multiple routers on a single physical router, right? So one VRF is equal to one router, and VRF is what? Virtual router and forwarding, right? So now there will be some limitations to create VRF on a single device. Like on some platforms you can create up to 32 VRFs, on some platforms you can create up to 16 VRF, on some platforms you can create up to 64 VRF. So this feature will vary as per platform, right? So it will be depending on your platform that how many VRFs will be supported by a single device, right? So now we are going to create this VRF. I'll let you know that how can we create VRF on a router, and then after I'll let you know that how can we put our interfaces into VRF. One more thing, you could ask me that, okay, so, like for an example, we have created 10 VRF on a single router, right? And that router was having only 4 interfaces, 4 physical interfaces. Now what is the advantage of creating VRF? So we can create sub interfaces, right? We can create some sub interfaces, and then we can allocate those sub interfaces into different VRFs, right? So it is also possible to put sub interfaces into different VRFs, right? And one more thing, you cannot put single interface into multiple VRFs. You cannot put same interface into different VRFs. That's not possible, right? So you have to put your interfaces into you have to put your interfaces into a dedicated VRF only, right? So that's the uses of VRF actually, right? So the point is, for an example, like this is your service provider router, right? And one customer A is there, A one side, and this is customer B, different customer, right? Customer B one side, right? And customer A1 site is terminating on service provider router, and customer B1 is this site is also terminating on this service provider router. Then customer A is also having another site that is called A2, right? Then customer B is also having another site that is called B2, right? And these sites are also connected with service provider router. Now let's assume that customer A1 is using some lane prefixes 10.1.0/24 to 10.1.5.0/24, right? So these 5 prefixes are used by customer A1 site, and then let's say that 10.1.6.0/24 to 10.1.10.0/24, these prefixes are used by customer site A2, right? And similarly, now customer B1 is also using same prefixes, because these are private networks and all are free to use private networks, right? So let's say that customer B has also decided to use the same prefixes to use same networks, right? And now they are using some routing protocols in between service provider and customer B1. So now let's say that customer A2 wants to reach customer A1. How will you provide this guarantee to service? I mean, how will you get this guarantee, or how will you get this confirmation that your traffic will be delivered only on customer A1? It is also possible that service provider can forward this traffic into the direction of customer B1, because customer B1 is also using same prefixes and also advertising same prefixes. So basically, this service provider router will be taking decision based on, first of all, it will compare longest prefix match, second it will compare AD value, and third metric. And if everything is same, then it will start to perform equal cost load balancing. So this is the problem actually. Now you have to use different routers for each customer, right? Like you will purchase one router for customer A and another router for customer B. So you will require to have two physical routers now. But with using VRF, we can achieve this task with using a single router. What can we do? We can create multiple VRF on a single device of this service provider router, right? We can put this customer A into a separate VRF and customer B into a separate VRF, right? I mean, we will create two separate VRFs and we will allocate those VRFs to these customers accordingly. Like we created VRF A on service provider router, and we will allocate these interfaces on which customer A is terminating, right? We will allocate those interfaces into VRF A, right? Or we will put them into VRF A, and then we will create another VRF on this service provider router itself, that is VRF B, and I will put all those interfaces where customer B is terminating into this VRF B, right? So basically, this is the advantage of using VRF. So basically, remember that traffic can't move from one VRF to another VRF, routes can't leak from one VRF to another VRF till now. In future, of course, we will be performing that as well, because it might require to leak your routes from one VRF to another VRF. Let's say one customer wants to communicate with another customer, right? At that moment, you might require to leak routes between those two customers, right? Which means that between those two VRFs, because ultimately you will be using a dedicated VRF for a dedicated customer, right? So this is the uses of VRF. I hope that you people have understood it. This is vrflite actually. I'm not talking about VPNs and all these things, right? So this is the simplest way to use VRF. Understood? So remember, by default, traffic can't move from one VRF to another VRF. By default, routes can't move from one VRF to another VRF. So this is the default behavior of VRF. Any problem? So let's start this vrflite now, right? So in this vrflite, I'll let you know that how can we implement all the routing protocols like EIGRP, OSPF, BGP, RIP with using VRF. So that's, I mean, like for an example, if you are implementing VRF without MPLS, that's called vrflite. If you are implementing VRF without MPLS, that's called vrflite. If someone asks you that what is vrflite, so you will simply tell that if we are implementing VRF without MPLS, that's called vrflite. That's it. So here I'm not going to implement MPLS right now, right? I'll be simply implementing only and only VRFs, and then after I will combine both of them. I'll implement VRF along with MPLS, and that will create, or over there we will be creating MPLS VPN actually. Fine, so we will discuss it later on, but right now let's start vrflite.
If we are calling VRF on a logical interface, then what would be the connectivity between C to B?
It will, which means that you will be having some switches over there, right? You will be having some switches. Let's say that you are having only one port available onto the service provider router, right? Then you can do one thing. You can let's assume that switch is there, right? So between switch and router, you will be having a trunk port, and then you can create sub interfaces as per VLANs, and then customers will be, I mean, you will put all these customers into their appropriate VLANs. I'm going to do that. Don't worry about that. I'll be using a single interface on service provider router, right? So I'll be using sub interfaces, and you know very well that on fast Ethernet link, if you are creating sub interfaces, which means that you have to put all sub interfaces into different VLANs. That's mandatory. It's not like serial interface, because in serial interface it's not necessary to have VLANs and all these things, but on Ethernet links it's mandatory. So I'm gonna to draw this diagram. Let's assume this is service provider router, right? And this is customer A1, this is customer B1, and this is customer A2, and this is customer B2. Let's allocate their names as well, and then I'll be having one switch as well, right? This is your Ethernet switch, this is your Ethernet switch, right? So this is going to be now, this R1 is going to be service provider, right? Fine. This R2 is going to be customer A1, and this R3 is going to be B1, right? And this is going to be customer A2, and this is going to be customer B2. I mean, this is customer B actually, and another site. Fine. F0 by 0 to this switch, F0 by 0 to this switch, F0 by 0 to this switch, and F0 by 0 to this switch. Finally F0 by 0 to this switch, 0.5, right? These are their interfaces. You can look at there. This is 2, this is 3, and this is 4, and this is 5, right? Port number 5. Fine. And this is only one port available on service provider router, right? And I think this is going to be difficult for you. Fine. So see, if you put in this diagram like customer A in same VLAN, then you know what will happen. Even they will not require this service provider router to communicate with each other, and that will never happen. Of course, your link will be terminating on a router. It's not it. Just try to understand. If I put customer A into same VLAN, like both sides into same VLAN, right? That I can do here, right? Because both routers, both sides are terminating on a single switch, on a same switch, right? I can do that. But if I do that, I will not require to have this service provider router anymore, and I will not be able to perform this practical of VRF, right? It will not require anymore. So what will I do? I'll put this customer A1 site in VLAN 10 and this A2 in VLAN 20, and then I have to use different subnets for each VLAN, right? So let's assume that between service provider and customer A1 we are using 192.168.10.0/30 in VLAN 10. For VLAN 20 we are using, let's say, 192.168.20.0/30, which means .1 on service provider and .2 on customer, right? Because 1 and 2 will be valid IP addresses, right? Similarly, I have to use separate VLANs for customer B. So I'll be doing one thing. I'll be using VLAN 30 for customer B1, and subnet will be 30. Similarly, for customer B2, I'll be using VLAN 40 and IP address will be /30. Any problem? And this port must be configured as a trunk port because traffic from multiple VLANs has to go through this link, right? So this port must be configured as a trunk port. Then in the lane of customer A1, we can use like 10.1.0/24 to 10.1.5.0/24. These are the lane subnets, right? And in the lane of A2, 10.1.6.0/24 to 10.1.10.0/24. Any problem? And similarly, same prefixes we can use in the lane of customer B1, and similarly we can use in the lane of customer B2, right? And we will see that if we communicate from customer A1 with IP address 10.1.6.1, then definitely we must be able to communicate with customer A2 only, not customer B2, and that can be achieved with the help of VRF only. If you do not use VRF at the end of service provider, you see that service provider will be receiving same prefixes from two different neighbors, right? And then it will perform path selection based on longest prefix match, AD value, and finally metric, and everything is same, then it will start performing equal cost load balancing. Of course, that we will never want, right? So we are going to do it now. So let's start it from service provider itself or from switch. First of all, let's configure the switch in there. I mean, we have to create VLANs and we have to put this interface 5 as a trunk port, right? So you see that according to the diagram, one is in VLAN 10 and 3 is in VLAN 20. Port number 1 is in VLAN 10, it is an access port, fine. Port number 3 is in VLAN 20, is access port, fine. Then port number 2 is VLAN 30, port number 2 is in VLAN 30, add. Then port number 4 is in VLAN 40, is not it? You can see that. And then port number 5 is what? Trunk port, so it is not going to be access, so make it .1q, right? So now you see that it is now .1q, right? Any problem? Then say apply, okay. So we have put these interfaces in their appropriate VLANs, and we have also configured this port number 5 as a trunk port. Let's start doing configuration of service provider router first. Go to interface F0/0, you understand? And then say no, shutdown, right? And then you know very well that we have to create what sub interfaces, so .10 for VLAN 10, right? So say encapsulation .1q, right? VLAN number 10, and IP address is going to be, let me know about it. It is on /30, fine. Then go to interface F0/0 .20 encapsulation .1q 20. IP address is going to be 20.1 for VLAN 20, right? Then interface F0/0 .30 encapsulation .1q VLAN number, and IP address is going to be now 30. Then interface F0/0 .40 encapsulation is .1q space 40 VLAN 40, and then IP address is going to be now 40.1 on /30. Any problem? So we have created these sub interfaces on R1, but we haven't created any VRF yet. Now we have to create VRF, and it is very simple to create VRF and to allocate interfaces into a VRF, right? See, it is IP VRF and its name is what? Let's say customer A is simple A, right? Is simple A. Then, however, you know, in vrflite, if you are not implementing BGP, then you are not required to allocate anything else apart from it. But in vrflite, if you wish to implement BGP, then you have to allocate at least this RD. RD is route distinguisher. RD is what? Route distinguisher. Like for an example, in multiple VRF you are having same prefixes, right? But ultimately both prefixes are present on a single device, right? So how will it be possible to distinguish those prefixes from each other? However, prefixes are same. So to distinguish those prefixes, we are having here RD, route distinguisher. Any problem? And this RD is a 32-bit long value, 16:16. 16:16. So in this format you will be allocating it, and IP and address, and IP address colon and a network number, right? So you can say 1:1 as well. Doesn't matter, right? You can allocate anything.
In this case, it is not required. RD is not.
Yes, it is not required unless you configure BGP, right? Once you will start configuring BGP, then it will become mandatory. But for VRF, right? If you are implementing BGP for VRF, then only it will be required. But in all other routing protocols, it is not required anymore, right? But still, I have allocated it, right? Then IP VRF is what? B. RD. You cannot allocate same RD to different VRF. You know why? Because if you are already having same prefixes into two VRF, and RD is also same, then how will it be possible for router to distinguish them, right? So it is mandatory to allocate different RD to different VRFs. So RD is going to be this time 2:2. Any problem? So this time I have created these two VRF over here, and to see them, show IP VRF. Is there any interface in any VRF till now? Right? So now point is that how can we allocate interfaces, or how can we put interfaces into VRF? So it's very simple. Let's say we wanna configure interface fast Ethernet 0x0.10 in VRF A, because this sub interface and .20 will be used by VRF A. So I'll be see, to put this interface into VRF A, command is very simple: IP VRF forwarding and VRF name, that is A. Now there is a rule. There is a rule that whenever you will be putting any interface into any VRF, or you will be removing any interface from any VRF, IP address will always be removed from that interface. You know why? Might be, let's say that you are putting an interface into any VRF, and in that VRF any other interface was already having the same interface, right? It is possible. See, you are going to put this interface into VRF A. It was also possible that in VRF A we were already having an interface with same IP address. So it was possible, right? So to eliminate this possibility, actually this rule is always there, that whenever you will put any interface into any VRF, or you will remove any interface from any VRF, understood? It will always remove its IP address. So that's why it has removed this IP address. So you have to reallocate it. So remember, in troubleshooting, because in lab you will be creating your VRF by yourself, right? But in troubleshooting, let's say VRF is there, and you came to know that okay, VRF is not configured on its appropriate interface, right? And you tried to configure VRF onto that interface, and you configured it, and it will remove IP address from that interface. It will show you only IP address, not its subnet mask. And now you won't be able to know about its subnet mask. Might be it was on /26, might be it was on /27 or 28. You will never come to know. So it is mandatory before allocating or before putting an interface into any VRF, make sure that what is an IP address along with subnet mask. Otherwise, now you will require to reload this router without write, and if you have write configuration, now you can't do anything. So you have to be very careful before allocating interfaces into any VRF, right? Fine. So this time I knew that. Then go to interface f0x0 dot IP VRF forwarding A. and IP address is going to be once again IP route. Does it have anything? Yes, it has 30 and 40 because we haven't allocated VRF on those two interfaces, right? I think we have put only first two sub interfaces only, right? Do show history. So you see, we didn't configure actually VRF. Yes, on 30 and 40. Dot 30 say IP forwarding, IP VRF forwarding, that is B, and IP address is going to be 30.1. Then interface F0 by 0 dot 40 IP VRF forwarding B, IP address is going to be 40.1. So IP interface brief. Yes, it is showing me that these IP addresses are allocated, but does it have anything in its routing table now? Because now in its global routing table, we do not have any interface available. There is no interface available in its global routing table. That is why it is not showing you anything over here. There is no interface where you allocated an IP address and member of global routing. There is nothing like that. That is why you can't see anything over there now, right? But you see, show IP VRF. It will show you that okay, you have put these interfaces into these VRFs, right? And then after you can also see show IP route VRF for what? It will create a separate routing table for each VRF. You see, now you will find those interfaces as directly connected, right? That is why we are calling it as a virtual router. Similarly, you can see for B. Check it out. This is for B, 30 and 40 subnets, right? Any problem in it? Fine. This is the configuration of service provider router. Now let's move on customer A1. And customer A1 doesn't know anything about the VRF, right? Here we will be doing simple configuration like F0 by 0 is going to use 10.2, right? And then loopbacks. It's going to use 2.1, 3, 4, 5, any problem? Similarly, we can have console of customer A2 now. Customer A2 interface F0 by 0, IP address is going to be now 20.2. And .1.6.1. What? 252, right? Then interface loopback 1, 10.1.6.1/24, and then this is 7.1 loopback 3. This is 8.1, and this is loopback 4, 9.1.5, and this is what 10.1. Right, So I have done this configuration on customer A2 as well. Now let's move on B1. And on B1, you see that on F0 by 0, right? 181.68.30.2, and then loop back 1, then dot 1 dot. I can copy and paste from customer A1, right? To show history. Customer B1, right? And then similarly, how to configure customer B2. F0 by 0 is going to have an IP address 40.2. Right, I have allocated an IP addresses, right? Now you see, by creating VRF, like if I move on customer A1, see I'm customer A1, and if I want to communicate with 10.1, I must be able to communicate with that. You know why? See, whenever this customer A1 will send traffic, it will send it without any problem, right, out from F0 by 0 after creating like ICMP packet, right? Switch will receive it in VLAN 10, will forward it out from the trunk port after adding the tag of VLAN 10. Router will receive it with the tag of VLAN 10, which means subinterface.10, right? And subinterface.10 is member of VRF A. So this time this service provider will perform lookup in its VRF A. You see 10.0 and 20.0. So it will come to know that, okay, because see, it will receive this packet within VRF A itself, because that interface was member of VRF A. So it will perform lookup in VRF A only. It came to know that it is directly connected, right? And it created ICMP to reply back and forward it in same manner, right? So it will never require to create VRF at the end of customer. Only service provider will be creating VRF at their own end, just like this example, right? Now let's configure some routing protocols. So between service provider and customer A1, what do you want to configure? RAID, PICRP, OSPF, or BCP? What do you want? OSPF? Fine. Let's start it with OSPF on customer A1. Router OSPF1, router ID is what do you want to take? Then 1111, right? The network 000, and area going to be 0. Show IP OSPF interface brief. Right. Now we have to implement OSPF at the end of service provider as well. This is your service provider now. Router OSPF. Process ID. Let's say we are taking. In OSPF version 2, it is not possible to create address families. But in OSPF version 3, now it is possible to create address family as per VRF. But here in older version of OSPF, you have to implement OSPF along with VRF in this manner only. That is why process ID came into the picture. One process ID will represent one VRF in OSPF. You know, we are always confused from CCNA, like why are we using process ID if they do not have any significance. So basically it will map this process ID with VRF. So every time whenever you will be looking at the database table or neighbor table, you understand, for OSPF, you will not require to mention your VRF every time. No, you will simply require to mention your process ID. Like here, I'm gonna to map this process ID 1 with VRF A. Like router ID is, for an example, 10.10.10.10.10. Any problem? And then say network 192.168.10.1, and area is going to be 0. I just enable OSPF on this interface, so it has formed neighborship. You see, and between with another site, like here for customer A we are having one another site as well, right? So which routing protocol you want to configure between service provider and customer A site 2? Same or different? If you will use same routing protocol, then you will not require to perform redistribution. But if you implement different protocol with the difference, between two different sites, right, then definitely you will require to perform redistribution. So what do you want? Let's perform redistribution, right? So let's configure EICRP now. So let's move on customer A2 and configure EICRP, router EICRP 100 node assembly network 0000. Fine. I have implemented EICRP on customer A2. Now let's move on service provider, right? And go to router EICRP. You can take any AS number over here, right? Because here you do not have any option to call VRF. Now within the EICRP, create address family, like we created in BGP, right? So create address family inside EICRP itself, and in named mode it is mandatory all the time, right? So say address family IPv4 VRF, and VRF name is what? A. Here in this EICRP classic mode, you do not have an option to call your AS number along with address family, but in named mode you will call your AS number along with your address family command, like there will be a command autonomous system right after it. But here autonomous system will be configured within the address family, inside the address family, right? Say autonomous system, that must be same as that you configured on customer router. Now this AS number must be same as that you configured on customer router. This is mandatory. If it does not match, then it won't be possible for service provider router to form neighborship with that customer router, right? With using EICRP. And then after say network 191.68.20.1 and then wildcard mask. Now it must form the EICRP neighborship, right? So it has formed. That's very simple, right? And I think you have to say no auto summary. That is mandatory, right? Because in classic mode auto summarization is by default enabled. Fine. Now if you say show IP OSPF neighbor, yes, that is, but in process 1, this is in process 1, right? Show IP OSPF 1 neighbor, this is for process 1, you see, right? And then show IP OSPF database, it will show you that okay, this is for process ID 1. Here it won't show you VRF, right? That is why I said that this process ID will be mapped to your VRF. And then after, if you say show IP ICRP neighbor, it won't show you anything, because globally you are running AS number 1. Globally you are running. So now if you say show IP protocol, it will show you only AS number 1. It won't show you anything else. But if you say show IP ICRP VRF A neighbor, then it will show you that you are running AS number. Even if you say show IP protocol, show IP protocols VRF A, it will show you now that okay, OSPF is running for VRF A. Second, EICRP 100 is also running for VRF A. You see, it's not it. And if you look at show IP route, you will see that you will not be able to get anything. You have to look at show IP route VRF A. Now you will see that some prefixes are coming with the help of EICRP and some of the prefixes are coming with the help of OSPF. But still customer to customer there will not be any communication, right? Now you have to perform redistribution, because at the end of customer A1 you won't be able to see anything. Show IP route, check it out. On A2 there is no. There's no route available on A2 as well. Now let's move on service provider and let's perform redistribution. To perform redistribution, it is same as previously, but make sure that this time you are performing redistribution for VRFs, right? So you have to say router EICRP globally you are running 1. Then say address family IPv4 VRF is what? A. Then you have to say redistribute OSPF 1 VRF, that was A, right? And then you have to say what? Metric 1544, let's say 0, 245 and 1 and 1500. So you have performed redistribution from from OSPF into EICRP. Now you can look at the topology table of EICRP. To look at the topology table of EICRP, you have to configure this command, show IP ICRP VRF A topology. Check it out. So you are having now redistributed prefixes, see, which means that redistribution has performed successfully. Then just come outside and redistribute EICRP into OSPF now. Say router OSPF 1 VRF is what? A. And then say redistribute EICRP, you understand? And that is 100. And then you have to say subnets. Even you can also define your metric type, that is by default, sorry, 2, and you can configure it as 1. Now you look at the customer A1 site and you must be able to see all the prefixes available over here. You see OE1 as type 5 LSA, right? And if you look at EICRP, I mean A2, customer A2 itself, then you will be receiving prefixes coming with the help of. And if you try to ping with 10.1.1, you must be able to ping with that trace route 10.1.1, 10.2, right? Even on customer A2, now you can do one thing. You can say enable password is Cisco line VTY024, password is again what? Cisco. Go to customer A1 and then you can try to take telnet of 10.1.1, sorry, telnet 10.1.6.1, right? That is available on another site. So Cisco, and this is customer A2, right? So you can ping with all of them, 10.1.6.1, you can ping with 10.1. Any problem? So this is for customer A. Similarly, you will be doing configuration for customer D. So this time let's take combination of RIP and BGP. So we will cover all the routing protocols. See, now everything will be configured within the address family. See, I have told you that how can you configure a routing protocol for a VRF. Now go to that mode and then whatever you want to configure, you can configure, like distribute list, offset list, whatever you want to do now, right? You can do that. Now let's configure BGP and RIP. So here for VLAN 30, I will be implementing BGP, and for VLAN 40, I will be implementing, for customer B2, I will be implementing RIP. So let's start from service provider itself. So router BGP you can take, let's say a service provider is using AS100, right? And you can say no BGP default IPv4 unicast. You understand? Default, you have disabled default address family, and then you can also allocate BGP router ID, and that's mandatory to allocate BGP router ID. You know why? This time you do not have an interface. This time you do not have an interface which is participating in global routing table and having an IP address. Because you are running this process of BGP globally, it will try to pick router ID from those interfaces which are member of global routing table. But this time there is no interface available which is member of global routing table and having an IP address. There is nothing like that. So it won't be possible for BGP to start process without having router ID. So it is mandatory to allocate router ID. Even I would show you now. See, you say address family IPv4 VRF, and VRF is what? A. And then say neighbor, that is 192.168.30.2, and remote AS, let's say it is running 65500. Understood? Just come outside. And then let's move on customer B1, and on B1 you have to say router BGP, let's say it is running 65500, right? And then say neighbor 30.1, remote AS is what? 100. Say redistribute connected. Now go back to service provider, say show IP BGP summary. BGP cannot run because router ID is not configured. Understood? So router BGP 100, BGP router ID, let's say 10.10.10.10, whatever it is, right? Now it will start doing work. Even it's shown you this It generated this log message that BGP could not pick a router ID, please configure manually. Just because of it is not having any interface in its global routing. Check it out. Because to pick router ID dynamically, there are some simple some simple methodology. Like first of all, statically configured, then highest loopback, then highest physical interface IP, but it was not having anything. That is why it was not possible for BGP to pick router ID dynamically. Now, BGP neighborship must come up, but it won't come up. BGP neighborship. BGP neighborship will not come up, right? You know why? Because at the end of service provider we configured it for VRF A. However, this IP address is part of VRF B. So you do one thing, go there and just remove this address family now. Say address family IP V4 VRF B. Say neighbor now neighborship must come up. Yes, neighborship has came up, you see. And you know, command will get changed now. If you are implementing BGP for VRF, right, you can't see your BGP peering in this manner. Show IP BGP summary, no. Show IP BGP neighbor, no. VRF works as a VPN for BGP. Remember, VRF works as VPN for BGP. So you have to add this keyword. So IP BGP, VPN V4. And if you are using IPv6, then you have to say if you remember your VRF name, then mention your VRF and VRF name. Let's say that it is A, and then say summary. Does it have anything? Sorry, but for VRF B, yes, it has. And if you don't remember your VRF name, after VPN V4, say all for all VRF, and then say similarly neighbor, similarly all, enter BGP tables. It will show you BGP table. After all, simple, enter. It will show you BGP table. So this is the BGP table, right? It received it from 30.2. Right? Now I'm going to implement RIP for VRF B2, right? I mean customer B2. So say router RIP. You don't need to define anything. Within RIP you have to create IP V4 VRF. That name is B. Say version, auto, and network. Fine. This is vrflite actually. I mean, whatever I'm doing on service provider router, this is called vrflite. Now let's move on customer B2, router RIP version 2 node assembly network. Fine. Now on service provider router, show IP route VRF A. It was already having all the routes available in VRF A with the help of OSPF and EICRP, but for in VRF B, it will be having routes coming with the help of BGP and RIP. Just wait for a moment. Show IP RIP database VRF B. Yes, it is enabled. requirement. On customer B2, show IP route, show IP RIP database. Yes, that's good. Can we ping with ping VRF, right? 40 dot. Yes, it's not communicating with that. Some problems are there. Show IP VRF dot 40, show run interface f0 by 0 dot 40. 40.1, that's fine. Customer B, yes, that's fine. At customer B2, show IP interface brief. 40.2, yes, show run interface f0 by 0. Fine, that's fine. Now might be some problems are there. On 4, port number 4, this is VLAN 40. Yeah, that's fine. Service provider debug, IP debug, IP packet, let me capture this link. This is the problem of virtualization. Yes, request is coming, right? On this link.
Vishnu.
Request is going there. Shut. No, shut. Show IP interface brief. Show run interface fast internet 0 by 0 dot 40. Is there any problem now? No, right?
Anil.
Some problems are there. Now don't switch actually, because packets are coming to this router. This router is not responding back. Fine, let me do one thing. No interface fast Ethernet 0 by 0 dot 40. Interface of 0 by 0 dot 50 encapsulation dot 1q 40 IP address before IP address say IP vrf forwarding B. IP address is going to be now 40.1. So IP interface brief. Do one thing, do ping vrf B, and that is 40.
नंबर चेंज कर लो सर उसके लिए 50 मिला
Where? On switch. Port number 4. Let's make it 50, right? Dot 50 encapsulation. Dot 1Q. Okay. In place of this 40 only, I'm using now 50. That's it. But this is not a technical issue.
कॉन्फ़िगरेशन में प्लेन 40
कहाँ पर?
वो फिल्टर करने का क्या है बाय डिफॉल्ट अगर तो कुछ बिकॉज़ इट इज शोइंग प्लेन 40
Might be. Fine. That is the default access VLAN. However, that port is working as a drum port. But might go through that. It was creating problem due to that one. Fine. So this time, show IP, route, VRF. Check it out. B. All routes are available, right? Now we have to perform redistribution. First, let's perform let's redistribute RIP into BGP, right? Router, and you see routes are same. Show IP route vrf A, vrf B. B, right? Say redistribute. That's fine. Sorry, say metric 1, right? Or 2 or 10. I mean hop count. Just come outside. Then router BGP 100 address family IP v4 vrf is what? B. Say redistribute. That's fine. And now you must be able to see all the routes available on B2, sorry, on B1 as well as on B2. You see, is not it? All of the routes are coming over here. Similarly on B2, all routes are available over here as well. Any problem? All of them are having same routes. Both customers are using same prefixes, right? I'm going to enable pass. I'm going to configure telnet over here. Cisco line VTY024 password is Cisco, right? And we can move on customer P1 now, and we can try to ping with the 10.1.6.1. Yes, it must communicate with that. What is the problem now? .40. Show IP route vrf B. Check it out. Yes, routes are there. Okay, fine. On customer B2, I'll be saying debug IP ICB, and then on customer B1, I'll try to communicate with that once again 10.1.6.1. It is saying echo request sent. Replies given by it. Then where replies are missing, replies are coming from there. You see echo request is delivered onto here, onto B2, and replies are also coming from B2 to B1, but somewhere they have dropped it. Fine. To solve this problem now, to solve this problem, what can we see here on P2 IP route? So it is giving reply back to okay. In RIP you can see that you do not have 30's prefix 191.168.30 dot, and that is running here, right? And that was not redistributed from BGP into RIP, because BGP redistributed only those prefixes which were learnt through BGP on service provider. You can look at there. Show IP route VRF B BGP. So basically, if I am pinging from customer B1, in source it is taking 30.2, but if I put source is loopback 1, it will work fine, because at that moment it is not having reverse path. Customer B2 does not have this 30's prefix in its routing table. To have that, on service provider router, you have to do one thing, say router rep address family IPv4 VRF is what, B, say redistribute connected as what. Right now you must be able to see this 30's prefix on B2. Swipe it out, you see 30's prefix. Yes, it is there now. And now if you ping from customer B1 without putting source, it will work fine. Right? So there was a problem related to reverse path. So in this way they can work. And now how, see, from customer A1, I'm pinging same IP. It is pinging. From customer B1 I'm pinging same IP. It is pinging. But how can we verify that customer A1 is accessing customer A2 only and customer B1 is accessing customer B2 only? For that I'll be taking, what is this? A2. And from customer B1 I'll be saying telnet and this is right. Both customers are using same prefixes, but still service provider is separating their traffic. If you want to know about traffic flow, then I can elaborate it to you. Otherwise, I don't think so that there will be any problem. Because see, if it receives, there is a very simple method. If a router is receiving any packet on any interface, it will look at that thing that on which VRF this interface belongs to. To which VRF this interface belongs to. If the interface is belonging to VRF A, then it will be performing lookup. It will be performing destination lookup in the routing table for VRF A only. And if interface was the member of VRF B, then it will be performing destination lookup in the routing table of VRF B only. If they do have prefix, destination prefix in their routing table, then it will work fine. Otherwise, it will simply drop your data. So this is the way to implement VRF Lite. If you are having any issue in it, please let me know.
So it creates different rib and rib for engineering.
Of course, everything. It will create different RAPE, FAPE, everything. LFAPE if you are implementing MPLS. Yes, MPLS will be configured globally. That is different thing, but we'll discuss all those things later on.
Or VRF A in between service provider and customer A to the component EAR. So before address only we gave an autonomous system number for area that was one.
And that is not like it should be same as that you configure on customer. You can take any ES number.
It can be same
I don't think so. I don't think
if
so.
you keep it same.
I don't think so that it will work fine. Let me do that. Yes, it can take. It can take, but it can be anything, which means that it can globally you can take any number. Then for VRF you can take any number, because both things are different from each other.
And RD are significant locally or end-to-end?
Locally. In VPN, I'll let you know that what is the uses of that at the moment of VPN only. But for now, that's enough.
How can we check that?
In your security, this is the only thing that you need to cover for MPLS. I think you are having only VRF, right? Nothing else.
Sir, how can we check that how many VRF my router can support?
It depends on platform. Whenever you will be buying any platform, then you have to ask to your provider.
Data sheets. Technically, you say significance. Separate 2900 support up to 50.
Fine. So this is the way to configure all these things. Apart from it, I hope that you can implement it now, right? Because commands are still same. You just need to change you just need to modify mode. Like you have to use address family, but OSP version 2 does not support address family. So you have to be very careful if you are implementing OSP version 2. But yes, in OSP version 3, this problem will get resolved because now OSP version 3 has started to support address families.
OSP was
Version 3.
global mode.
Yes. But VRF is, like process ID is mapped to process. Yes.
That we need to remember.
Fine. Then after it, let's go for static routing for VRF, right? That how can we configure static routing? Or in other words, I will say that how can we take traffic from global routing table to VRF and from VRF back to global routing table? That is also possible, right? You can take your traffic from global routing table to VRF and from VRF into global routing table with the help of static routing. So now let's go for that. I'm gonna do of this topology, and I'll be using very simple topology for this practical now, and I'll be using 3 routers only. Like this is what router 1 and router 2, and this is what router 3, right? I'm gonna do interconnect all of them, and let's assume that this is this portion is in VRF A, and this portion will be member of global routing table 12.1.1, and this is what 12.1.2. Here let's say we are having a loop back 1111, and here on R3 we are having loop back. We have to establish connectivity between them. So this 3.3 is in VRF A, right? And this complete portion is in it's quite simple. Loop back 1, sorry, F0/1 IP. First of all, you have to create IP VRF, and that is A. And then go to F0/1 IP VRF forwarding is what? A. IP address is going to be right. Fine. Then on router 3. You don't need to put both ends in same VRF, right? Don't think that okay, we have to put this R3 in VRF A itself. No, you don't require to do that, because finally traffic has to go through R2, right? And R2's F0/1 is already member of VRF A. So 333, and it does not make any significance as well to create VRF on R3, because already we have created this VRF on R2, right? To move on R2 now, show IP route. In global routing table, it will show you only 12 network. If you say show IP route VRF A, it will show you 23 network, right? So we are having two separate routing tables now. Fine. What is my task? To communicate with the loopback of R3 from the loopback of R1. So first of all, R1 will perform lookup in its routing table to reach 333. Does it have any information about 3? You see, does it have that? No. So you have to say IP route 3333 245 245 245 245, and next hop address is going to be so IP route. Check it out. Then it will reach R2. R2 will receive this packet on F0/0, and this F0/0 is member of global routing table, right? So it will perform lookup in its global routing table for destination, right? Does it have anything in it? No. So you have to say IP route, and that is 333 and 5, and then fast Ethernet is what? Exit interface is 0/1, and next hop is 23.1.3. Make sure that if your exit interface in VRF, then it is mandatory to specify your exit interface, right? That's mandatory, along with the next hop address. Show IP route. So I have defined it. Now it knows that how to reach 3333, right? So finally 333 will be delivered on R3. Now R3 will respond back to 111. Does it have any information about 1111? No. So you have to put, and next hop address will become right. Now packet will come back to R2. R2 will receive this packet on F0/1. It is a member of VRF A. Will perform lookup in VRF A. So IP route VRF A. Does it have that how to reach 111? So now you have to put, you have to configure static route within VRF A. So you have to say IP route VRF, which is A 1111 245 245 245, and exit interface is what? Fast Ethernet 0/0. Next hop address is what? 12.1.1, and this is member of global routing table. When you configured static route in global routing table for VRF, then it is not required to specify any keyword like this. But if you are specifying static route within VRF for global routing table, then you have to specify this keyword global, as I configured here. You see, this is that you configured in VRF A. Show IP route, this is global routing table, and show IP route VRF A. This is for VRF. Now you can try to ping from R1 when source is its own loopback 1. So you can take your traffic from global to VRF, back from VRF to global. That's what they do when they configure a default route in VRF, static default route for the customer to access an internet.
And if there are multiple VRF, you can just mention the sub interface. Map it to the particular VRF.
And I think that is also possible to call loopback. I think so over there. Like you can create multiple loopbacks on a single globally, right? In global routing table, and then you can call those loopbacks as next hop. I think so. I mean, something is there that they do.
directly have to do between two VRFs route.
That's different. That's completely different. That can be possible with the help of MPLS VPN only. That's possible with the help of VPN only. That's not possible. Yeah, routes can move from one VRF to another VRF without configuring MPLS VPN.
In vrflite it's not.
No, it's not possible. Route leaking is not possible. Yes, you can take traffic from one VRF to another VRF as well, but you have to do in that manner, like one VRF to global and then from global to VRF. You can't take traffic directly from one VRF to another VRF. No. First VRF to global, then global back to VRF in this manner. Right, so this is the way to implement vrflite, and